All right, good morning and good afternoon, everyone. Thanks so much for joining us for this webinar titled Handheld Lasers Managing Risks to Maximize Benefits. My name is Liliana Caldero. I am the Education Manager for the Laser Institute of America, LIA. LIA is proud to be hosting this continuing education opportunity today. Free registration for this webinar has been sponsored by IPG Photonics. IPG Photonics is the world leader of fiber laser technologies used primarily in materials processing and other diverse applications. Their mission is to develop laser-based solutions that apply light to transform the world around us. IPG manufactures the LightWeld line of handheld laser welding and cleaning products. LightWeld systems features or incorporate industry-leading technology to help users maximize productivity, as well as innovative laser safety features which differentiate it from the competition. IPG is headquartered in Marlborough, Massachusetts, and has more than 30 facilities worldwide. This 30-minute webinar will be worth 1/4 Board of Laser Safety Certification Maintenance point. Certificates of attendance for those attending live will be emailed out by the end of this week. So with that said, I'd like to introduce you to our presenter, Dr. Rob Mueller.
Thank you, Lily. Welcome, everybody. I'm just going to dive into this. So yes, again, handheld lasers managing risks to maximize benefits. If you've been to a trade show on welding or any advanced technology recently, you'll see that there have been many companies coming out with these handheld laser welders, and lots of videos on YouTube showing people doing pretty amazing things with them. And the question really is, what safety is needed to work with these things properly? You'd see some videos and pictures, and like this picture here of a person with a hood with a laser window in it, gloves, jacket, and full welding safety gear. And then others where people have basically nothing, and that's confusing the world and potential audience and users, and we want to correct that. And what you see here is correct. What I may show you later, we'll show you a few things that are not correct. So, these handheld welders are relatively inexpensive compared to automated machines. Very easy to operate. I've done them myself, and it's within a few moments making a decent weld. So they produce very good results in a reasonably skilled hand. And some of the processes, especially cleaning, are very eco-friendly compared to competing technologies of chemicals and things like that. So, but the problem is safety for the operators and bystanders is not keeping up. Some people are doing a really good job of trying to explain to their customers what needs to be done, and others are not. So there are handheld lasers now for welding. Thank you, IPG, and cleaning. Many of those systems can do both tasks. There are also systems coming out for marking, and I've seen a few of the manufacturers of welding equipment saying they can also use their equipment for cutting. I'm not sure why I would want to do that, but it's available. So all these lasers, whether it's from small markers up to big welders, are based on fiber laser sources. They're all putting out a wavelength of light around 1070 nanometers, which is in the near IR part of the spectrum. And powers can range from 10 watts for a very small marker to 2000 watts and even higher. I've seen some samples for some of the welding and cleaning applications. Now, here's some of the do-nots. These are pictures taken from YouTube videos and web images of some sources, and no PPE at all, having a hand within literally 2 inches of the process. This person is wearing what we hope are proper laser safety glasses and even a glove, but the rest of his face is not protected properly and could be burned by a reflection. So these are things we have to try and stop from happening. All of them. So that's the main purpose of this kind of educational video or seminar. all the lasers we've discussed, for whether it's a little marker or a 2000-watt welder, are laser class 4 sources. This is the highest level of danger. By definition, they're a danger to the eyes, to the skin, and can start fires. And even the diffuse reflection from a beam like this can cause a hazard. Now, everyone's very familiar with the specular reflection. This is your common mirror reflection. Um, People may not know that it's a diffuse reflection, but most people would be familiar with it if you've ever seen a presentation using a red laser pointer or a green laser pointer, or played with your cat with a laser pointer. Um, the red dot that you see is the diffuse reflection. The laser beam goes from the pointer in your hand to the wall or the floor, and the beam scatters from that point, and you see it no matter where you are in the room. Um, Now, the other thing with this is that laser is typically no more than 5 milliwatts. And you go, okay, how much is that light? Well, that's the diffuse reflection from a 5 milliwatt source, is that little red dot on the wall. The lasers you are dealing with this welding process are typically 1,500 watts. That's a typical laser welding system. That is 300,000 times more powerful than this little pointer. Now, that's pretty hard to imagine, but I think if you think about that, that red dot is comfortable to look at. You can see it in a wide variety of lighting conditions. Um, a light source that is 300,000 times brighter than that, if I told you that would be dangerous to your eyes, I think you could imagine that it very well could be. So just think about that. We'll get to that. We'll return to the idea of a diffuse light and how dangerous it could be in a while. Now, in the next couple slides, I'm going to show some results of laser incidents. And these were not random accidents. These were the result of not following procedures given by competent manufacturers, or what are provided in the ANSI Z136.1 standard for the safe use of lasers. People neglected engineering controls that were starting the beam without being properly protected. We're not following standard procedures, not wearing proper personal protective equipment. So, hazards to the eye. People would say, okay, a welding laser is at near infrared. I can't see that color. And that's true. We don't see near infrared. Our photoreceptors don't respond at that wavelength. But the human eye actually transmits quite a portion of near infrared light. Here's the visible range, the graph in the lower left. Colors from violet, indigo, blues, all the way to the reds. That's what our photoreceptors respond to. But the structure of the eyeball transmits from 400 nanometers at the blue all the way out to 1,400 nanometers in the mid-infrared. This red line represents 1070, where the wavelength of fiber lasers. So fiber laser light gets into the eye, is transmitted by the structure of the eyeball, and is focused by the lens onto the retina. The photoreceptors don't respond. We don't see that color, but the light gets to the back of the eye, is concentrated by the lens, and can damage the retina. You think of that 300,000 times brighter light source than your pen pointer, that's going to burn a spot on the retina. So here's a image of a retina taken through the pupil. If you ever go to an optometrist and he sits there with a little telescope and looks into your eye, this is what he sees. The slightly darker region in this area is your central vision, where the photoreceptors cells are more dense, And this really dark spot is a scar where the photoreceptor cells have been burned and that spot does not respond to light anymore. And since they are photoreceptor cells, they're a specialized kind of nerve cell, they don't grow back. This is permanent. This is for the rest of your life, an injury, and you walk around with a little bit of your field of view missing. So this is why proper laser safety eyewear is always required every time you turn on that laser. Skin is not as sensitive at this wavelength for a couple of reasons. One, the beam is not focused like it is going through the eyeball. The other thing is that out at around 1070 nanometers, the penetration into skin is rather deep, almost near the maximum. And therefore, the heat is dissipated over a bigger volume of material, and it takes longer to warm it up. Now, if you get to the point where it is warmed up, the result is not just a surface burn, but a deep burn under the skin. I have a series of images here of someone who is accidentally exposed to 3 kilowatts of fiber laser. So this is about twice the power of a handheld welder. After an hour, the beam actually started here, and as he pulled his hand away, the beam actually went out his finger. He didn't optimize his exit path. So this is shortly after the incident. That evening, it was blistering up. 8 days later, you've got a pretty nasty scar. This area wasn't heated as much because he was pulling his hand away, so it's healing a little faster. 14 days later, this area is mostly healed, but the scar is still slowly closing there. So this took about a month to heal completely. And this is why you should be wearing skin protection for anything that is coming near the beam. Recommendations include leather welder's gloves, a face shield for any reflection coming back towards your face, and long sleeves that fully cover your arms. So, there are also hazards other than the beam produced by laser processes in general, including handheld laser welding and marking and cleaning. Um, the welding process is evaporating metal, releasing it up into the atmosphere. If you're welding steel or pure iron, iron's not so bad for you, but in steels, there are a lot of alloying elements that are not as friendly. Manganese, other things. If you go into stainless steels with the nickels and the chromiums, those are definitely bad for you. Working with aluminum, I don't want to be inhaling aluminum vapors. If you're doing processes like cleaning, where you're lifting oils and paints and other materials off of a surface, those materials will firstly break down, and you really have no idea what you may be ingesting or inhaling from that kind of a process. It could be irritants that just irritate your lungs or your eyes. There could be carcinogenic materials that are released or created in the breakdown of those products. The other issue is when you're evaporating these metals or other materials, they break down into and they can recondense into extremely small particles, which can be inhaled deeply into the lungs, depositing, we're not sure what material, deep into your lungs, and it can be a very long time before you're able to get that stuff back out. So for this kind of problem, you should have fume extraction. Either a little smoke hog, collect the smoke from your process, or something to prevent the operator from breathing in that smoke. Now, you can, there are standard calculations in the ANSI Z136 standard for the hazard zone around a laser. And we know the parameters for these lasers. We're just going to assume we have a welder at 1500 watts. Um, we know from the wavelength of that laser light that the maximum permissible exposure is 5 milliwatts per square centimeter. Typical condition for the welding gun head of a welder, focal length 150 millimeters, beam diameter on that focus lens is around 8 millimeters. This gives us hazard zone beyond focus for the direct beam for the eyes of 115 meters. That is a football field from goalpost to goalpost beyond the end zones. So if you were stood at one goalpost and fired that laser across, you could damage someone's eyes standing at the other goalpost, even considering that that beam is expanding over that whole distance because you're beyond focus and the beam is continuing to expand. Even for skin, which has a higher permissible exposure because it's not focused and it's absorbed over the volume, the hazard zone is 26 feet. You could injure someone with a direct beam. Uh, Now, the other one, that was the direct beam. This is the diffuse. There's a similar calculation for the diffuse reflection, that scattering glow of 1500 watts off a surface. For the eyes, even that scattered glow would be a hazard for a distance of around 10 foot away from the process. So anybody in that small space around the an active welder looking at it could be damaged. For skin, which has, again, the lower or a higher permissible exposure, you can be burned if you're within 8.5 to 9 inches. So the guy with the bare hand holding that piece to be welded, he's risking getting burned. And you go, well, why isn't it happening every time? It's because most of the power is actually being absorbed into the metal and being used to heat the metal to create the weld. If he ever gets out of focus or for an instant where the keyhole collapses and you have more light scattering away from the process than it's getting into it, he could suddenly get himself a burn. In conclusion, yes, these handheld laser devices can cause injury only if you ignore the hazards and neglect the controls. There are ways to work with this equipment safely. These are what I've shown are laser incidents. They are not accidents. This is not a random thing. This is people not following safety procedures and not using the equipment properly. Um, you have to use the required engineering controls. Things like the handheld welders typically come with a continuity sensor, a little wire and clip that goes onto the workpiece or onto the table under the workpiece. And the laser can only fire when the tip of the welding gun is in contact with the surface. Um, I have seen, I don't know how many cases on the internet where people, oh, just clip that thing to the barrel of the gun. And now they can fire it anywhere and everywhere they want. That's asking for trouble. Um, the operators provide standard operating procedure, manufacturer's instructions. Um, again, making sure that you are pointed only at the workpiece that you want to hit and never pointing at anybody or any direction that you're not under control of. And always, always wearing proper personal protective equipment. This includes laser safe glasses or a hood with a laser safe window in it, proper hood protecting your face, um, heavy leather gloves. So the beam could eventually burn through them, but for a few seconds, you're going to have that protection, um, and long sleeves to make sure that you don't get a reflection onto any other part of your skin. Um, we didn't talk about other controls like putting up barriers to protect bystanders. Um, in the full course, we'll cover that kind of information. And also, again, and signage. And the other thing, of course, is to get some training so that you understand why you have to follow these things every time. Okay, so this is an announcement for the Handheld Laser Safety Awareness course. This is a course that we're going to start giving in early February. 2-hour course on basically, it's a full laser safety awareness course, but geared specifically for handheld applications. Uh, so we'll cover all the topics of a laser safety awareness course, but we'll deal with scenarios like working in a dedicated workstation, working on a factory floor, maybe doing a repair or equipment maintenance, um, working in a shop for general fabrication or auto body repair, working outdoors in a storage yard, maybe marking product or something like that in a storage yard, or cleaning a building facade. How do you keep the world safe under those conditions? Um, or taking your equipment to a customer site to do, I've seen people doing laser cleaning of commercial kitchens or laser coating removal on people's kitchen cabinets for refinishing kitchens and things like that. So how do you keep things safe under those kinds of environments, that full range of environments? Um, the course will cover all the standard components of a laser safety awareness course, the basics of light and lasers, uh, laser safety basics in terms of the definitions and terms, the classifications, hazards to the eyes and skin and non-beam hazards, controls for laser hazards, engineering controls, administrative controls, personal protective equipment, signs and labels, um, uh, laser safety program information, the standards and what you include in this laser safety program, and a little bit more on the sample calculations to let people know what the range of that hazard zone is. This is why I gave you a few calculations here. I'm not interested in people doing those calculations, but I want to see the result and how big that hazard zone really is, because people are really not aware of that. So, um, and that's about it. So this course will launch in early February. The information will be on the LIA website. And if you have any questions right now, you can type them in the question box and we can answer them live. Okay, not seeing any questions yet. Oh, thanks, Neil. Okay. I have a question. How do you address reflectivity of target material? Um, we assume that it's the worst case, that it's very highly reflective. That's how you get a maximum for your hazard zone. In practical terms, it will always be less than that. But quite frankly, on shiny metals, whether it's molten steel or molten aluminum, the reflectivity can be pretty high. So using a reflectivity of 1 is not that far off. So um, does Z136.1 require a dead man switch on a handheld laser? Um, I dot one does not, because it doesn't address handheld lasers directly. Um, the dot nine standard is in the late stages of revision, and that may have something. I know that the like IPG and other similar North American manufacturers, IPG actually has a two-stage switch that you have a first stage trigger that you know that you've engaged, and then a second stage that actually fires the laser. And you cannot lock it. It's if you release the trigger, the system stops immediately. So, um, and then there is also the continuity sensor and some other things, including a plasma sensor to detect that the beam is actually hitting something and creating a plume that you expect. So that's how they tell. Um, you did mention that a normal welding helmet worn with laser eyewear is sufficient, or would you recommend wearing a laser welding mask and laser eyewear? Um, I alluded to the fact that you're wearing a hood, but I kind of assumed that it was a hood with a laser window in it. Um, Probably having a normal welding hood and laser glasses would make things too dark to be comfortable to see. So um, I don't think I would recommend laser glasses and a normal welding hood with, a number 3 or 4 shade in it. That's a bit too dark. So I would prefer to see people using a hood with a laser window in it that gives them proper visibility, because that means they'll use it more often or all the time. They don't feel the need to take it off. Okay. Will this course offer any insight into the international standards, such as the impending ISO 11533? Um, at this time, I had not planned on that, but I still have a little bit of time. And if someone wants to send me some information on what that standard involves, and how it affects laser safety of using the equipment, I'd be more than willing to try to include it. So, have you seen any of these handheld lasers in hospital settings? I have not, and I've not even heard of that. I'm really not familiar with medical applications of lasers. I've been industrial stuff for 40 years. Um, I don't even want to guess a hazard on that. Yes. What are some methods to evaluate hazards of the dust that are going into the filters if we process various materials? Um, that is an industrial hygiene question and not really a laser specific question. I'm sorry. Um, yeah, if you're working in a general shop and working with aluminums and steels and collecting dusts from both, you can make thermite and have a very big problem in your fume extraction system. Um, and I can see how that could be a really big problem and be a concern for an employer. Um, I'm not familiar with the methods to actually check and test what your filters are collecting and what combination of materials might be in there. So, um, does OSHA have any requirements for handheld laser welders? As far as I know, they don't have anything specific. Actually, the OSHA regulations don't mention lasers specifically at all, except under the general duty clause, where they bring in ANSI Z136.1. So I believe OSHA would probably defer to what is in the ANSI Z136 standards to control hazards associated with handheld laser welders. But that's my opinion at this moment. Okay. Um, are you aware of any laser resistance testing of welding gloves? No, I'm not, but that's a good question. Maybe the laser companies that are offering these machines may want to offer pre-tested gloves that they know will withstand the laser for, a few seconds at least. So that's a good question. Um, is it possible that the laser PPE, sorry, is integrated with the laser safety interlock? Um, that would be the gold standard, that you have to have your hood on and in proper place in order to turn on your laser. That would be very nice, but I don't know of any system for any hazard that actually has that level of control. Um, it'd be nice, but I don't know exactly how to do it. So, not all laser eyewear protecting in this range is green or distorts color. I'm not sure what the question is with that. Um, do you feel laser eyewear is sufficient for the bright plasma light? Good question. Um, yeah, that's a good one. I don't know what quantitatively how bright the plume is. I know it's bright. I've seen it from automated processes. Um, and yeah, it's not that easy to look at, but whether the laser protection is sufficient for the plume protection in the visible is a good question, and that's something that maybe should be addressed in the standards as well. There is sort of something in there about ancillary hazards, but um, we maybe want to try and quantify that a little bit. Do you see these? Oh, do you see these lasers being used to replace microblasting processes? A cleaning laser, very I could see that being directly competitive with that kind of process. Yes. Um, all right. How about medical grade laser? I use a 1470 laser for something. What is the risk and recommendation protective gear? 1470 is right on the limit of, it's actually slightly beyond the limit of what goes into the eye. So now you're looking at regulations for mid-infrared lasers. And um, I'm not as familiar with that. I can give you some indication. 1470 is more absorbed at the cornea and the lens. It doesn't really get back to the retina. So um, uh, the requirements and the protocols are a little bit different for that one. One hood vendor has an interlock system. Lift up hood, beam shuts off, which is nice. That's a good for a switch. But if the hood is in the closed position and taken off your head, it won't help you. So that's my concern with something like that. A couple of comments. Okay. Uh, I think we're running low on questions. Very good, folks. Is there any specialty requirement for ventilation and fume extraction? No. What you would use for a normal welding fume extractor also works for laser welding fume extraction or laser cleaning fume extraction. Okay. All right. How are we doing? We're getting low on questions here. We have a few thank yous, but um, all right.
All right. Well, if there are no more questions today, thank you everybody for joining us for this webinar. Thank you so much, Rob, for your presentation, and thanks again to IPG for sponsoring this webinar. We'll be sending out a follow-up email and including some information in there. So if you think of any other questions after this webinar, there will be some contact information there for you so we can do our best to help you with that. Again, certificates will be sent out by the end of the week for your attendance for this webinar. But with that, we will close. So thank you again, everybody.
Thank you, everyone.
All right, bye.